Hello. How's everybody doing? If you can, excuse me, if you can just in the chat, just give me a quick wave to let me know that you can hear me. Anybody? Maybe? There we go. Okay. So I got some good feedback. Okay. So today we're going to have just a quick, really a fun discussion. I think we're going to talk about, from my vantage point, what CIOs need to be paying attention to in terms of their AI architecture and why that matters in 2025. A couple of other things I think that it will be very important for you guys to pay attention to. So we've got a lot to talk through, so I'm just going to go ahead and jump right into some of my visual aids and my deck and, share here. Great. Okay. So today what we're going to talk through is I'm going to give you just a very quick intro to data stacks. We'll talk about why this matters, this topic, AI-ready architecture. We'll talk through all of the pieces, all the big chunky pieces of the architectural pillars, and then some organizational considerations, which I think may surprise you the way that I look at this way. I think you as an executive should be looking at this. So just quickly, data stacks, if you're not familiar with us, we've been around a very long time, 13 years. We have referenceable customers in literally every vertical. We've been helping them with their hardest data problems. It's usually their consumer-facing, high-scale database problems. That's where our company was built. But we've been doing a lot with all these companies recently to help them through their, over the last 2.5 years, learn and deploy AI. And here's the reason. We have really made a name for ourselves in the AI space, particularly with our vector database, which is, I've always said that good retrieval is the beginning of good AI, retrieval from data, and that depends a lot on vector search. So just letting you know, we've put up some really respectable um, products in this space. All right, so that's enough about us. Now, why does this matter right now? And so if you look at, obviously we're all very aware, I think, of the explosive growth of Gen AI and real-time inference. But I think one thing I've noticed is, particularly within the last year, we're starting to finally really get our hands around, as companies, around the utility of generative AI and how we can actually finally start to apply it in our companies in a way that is making a difference to our bottom line. But there's also challenges. There's some very new concepts when it comes to AI architecture, specifically how they can continually adapt. Historically, as we build applications and we deliver them to production, I think that we have a model of saying, okay, we build, ship, and maintain. But with AI, we're dramatically changing that paradigm where we have to be thinking about how the AI can evolve and keep up with the way that our users and the data that they are using changes. And that involves, you have to add some significant new pieces to our architectures to facilitate that learning and an adaptation. And there's some foundational things that obviously costs are a huge concern. Running AI, running these models are not cheap. How to govern them, and then how to actually deliver value in a reasonable amount of time. And I think those are rooted in things that we as executives generally have cared about for a very long time. But AI is kind of throwing us some new curves on that. But let's talk a little bit about, I want to show you sort of 3 proxy metrics to talk about, again, why we should care. One, if we think about what we can do effectively with these technologies, although we've started sort of the generative AI transformation, you call it late 2022 was sort of the advent of ChatGPT. That's when people started to really get their hands around, okay, this is a real thing that I can understand. I can start to do some useful things with it. But as you can see here, plotting out some of these models and the duration of the task, which is a sort of a proxy to complexity of task that they can accomplish, it's going up very, very fast. And now here, one thing I'll call out on the top of the title of this slide, this is plotting at a 50% success rate. And I think I talked to a lot of other executives who, when they see some of these metrics, when you start to put actual data around that you can measure around an intelligent entity, let's say that is a proxy to a person or an LLM in this case, or an agent, being able to complete a task or successfully, we look at 50% success rate and like, well, that's crap. But then if you start, I think one of the challenges is that we do not have a super clear way of measuring as the productivity or the accuracy of our human workforces nearly as rigorously. And I think that in many cases, if we dig into the success rate of any given task for someone in our workforce, many times it's actually not nearly as high as we think. It's just that we don't have a really great way of sort of quantifying and measuring what success is in a given, discrete task. So with AI, we do have that ability. So again, this is sort of a proxy for how useful this technology is becoming or can be. And then costs. Again, this to me is an indication of how cost effective is it getting for me to apply this technology. Now, just to help you digest this chart, these the purple and the orange represent two scores. So MMLU is the massive multitask language understanding. So it's just a test that we can administer to an LLM to see how intelligent it is in this case. But what we're doing here on this particular chart is we're saying, okay, well, for a given score, how much would I have to pay for 1,000,000 tokens? Because that's how we generally pay for at least the hosted LLM services, is you pay per 1,000,000 tokens. And so one takeaway from this is obviously we're going to be always be paying more for a higher score, which seems intuitive. But the other thing is, if you have ever wondered if the LLM wars were a race to the bottom in terms of price per million tokens, I'll call out that this is a logarithmic scale. If you look at the left axis over time, you can see these prices per million tokens are to deliver a given score are dropping precipitously. So that means that the technology is getting more and more cost effective for us to deploy and solve meaningful problems, those kinds of problems like these longer running tasks, because longer running tasks chew up more tokens, therefore have more cost. But because the costs are falling, this is definitely putting it more within reach for us. And this slide, this is a proxy again to another concept. So what these are, this is the current landscape of AI-assisted development tools. Now you might be wondering, okay, what does that have to do with this architecture? But what this has to do with is our people, our organizations. And so anybody in your organization who is generating anything that remotely looks like code, whether it's actual building software, or if they're building any kind of automation, any kind of operational scripting, deployment scripts, things like that, CI/CD, tons of the different kind of tasks that we expect of our teams. What we're seeing is this prevalence of tools is indicative of a trend toward dramatic you know simplification of and reduction of complexity of working with all those kinds of the codes the types of code that I just mentioned. So again, think of this as a proxy to how productive your teams, the people I just referenced a moment ago, are going to become, because this has a huge impact on uh, the kinds of products they will build, your time to delivery, and then most importantly, how critical the an AI-enabled architecture will be, because you're going to be able to deliver software and other knowledge products much faster than you have in the past, but only if you have the architecture to support it. Let's go through some of the pillars. I think that obviously we always have to start with the basics. The basics are the top line here, which is always on, scale, low latency for reads and writes. I'll talk about that in a second. Uh, global replication, multi-region. That's just like table stakes, I think, for most consumer-facing IT. If you're building a system that deals with your customers or your partners in any way, you must have these fundamental concepts down. Always on, can't go down, needs to be able to scale, has to be fast. One of the things I'm going to just poke on a little bit here, reads and writes. When we talk a lot about AI, one of the things I've noticed when I'm talking to a lot of executives is that we just naturally gravitate to thinking about the read use cases. And that's a little bit misleading in terms of the way that we reason about the problems and solutions and trade-offs, because if your data was read only, we can approach that architecturally from a very, very different vantage point. However, what we have to understand is that AI, although it may be pulling from knowledge sources that ostensibly maybe they're not changing super frequently, depending on your use case, but even if the knowledge that your AI is pulling from is static, like not changing at all, like a knowledge base or something, the use of that is going to generate new data, because you're going to be needing to be tracking how people use it so that you can fine tune your models, so that you can make the whole system better. So just the use of it creates rights. But outside of just that knowledge-based use case, which I think has been sort of the last at least year and a half of useful use cases in AI, people have been focusing on predominantly read-heavy use cases. But now we're starting to see many more use cases where AI is actually writing the data. So always keep that in the back of your mind. It's not just about reads anymore. It's also about writes, and that's super important because that's what databases are about. Obviously, that's the area that that DataStax specializes in, is in databases. So keep in mind that you need a system that's not just serving reads to these AI, but also can absorb writes. As sort of metadata that's produced by the write, as well as the write itself. The knowledge layer, going back to sort of the reading piece, we're going to talk more about that in detail. I mentioned earlier being able to build in how the system can evolve. We'll talk about that in detail. And then we have the new intelligent interfaces. Now, it's sort of I don't know, to be cynical in some cases, I look at MCP and A2A as sort of the next interface language. You could say RESTful interfaces, or even go back and look at SOAP interfaces, or whatever. There's obviously been tons of different interface frameworks, protocols, what have you. And MCP and Model Context Protocol and A2A, or agent to agent, are sort of a very recent evolution of sort of our list of different interfaces. And clearly these Model Context Protocol and agent to agent are specialized in their the way that they expose the capabilities of the underlying services that they provide interfaces to. We'll talk a little bit about that. But the point is they're different, but they're still just interfaces. They're just intelligent interfaces. Last two, getting into governance and lineage, and hybrid and multi-cloud flexibility. All right, let's talk a little bit about the knowledge layer. So if we look at this, from the bottom up, the first part is obviously the foundation. If it will click for me, foundation. So you have to start. You're still going to have a database or several databases of some sort to be able to support everything that you're doing. And then on top of that, this is where we're going to be building a new presentation layer, if you will, that we're calling the knowledge layer. And this layer is optimized for the new user of all of this data. And so obviously we have tons of data in our organizations, and we have humans that use those. We have some other machines that use them, but we have a new user that we're having to cater to, and that's the AI. And the AI does best if we present data to it in various ways that it can use to discover the data that it needs to reason about. And so these are a couple of different organization or sort of presentations that we found have been most fruitful in terms of empowering AI to find the data that it needs out of your private data and present it to the user in a useful way. All of these are built on vector search. Vector search or vector similarity search has been a real key to enabling all of these different techniques: GraphRag, multi-vector, and hybrid search, those all use vector search in some fashion. But vector search alone, in case you're wondering, is not enough. Some early on when we first started AI, a lot of people, myself included, thought, oh, vector search was going to be sort of the panacea, silver bullet that would sort of meet all of our AI needs. But it turns out that there are several areas of vector search is actually not great at. One is when we're having to discover data that is related to semantically relevant data. Sometimes a user may be asking a query that's not immediately, does not have any kind of context, allows us to actually find the most relevant data that they may need, because sometimes that most relevant data is actually related to something we can find that's semantically similar. Anyway, short version is we still need a way to represent relationships in data. And I don't generally say that a graph database, a specialized graph database is necessary for this. I think that if you've ever used a graph database, they are very good when you have data that is highly relational. And what I mean by that is that at query time, you're on average going to be executing a query that has 3 or more traversals to find the related data in one query. So that is, to use the typical social network example, I need to find my dad's friends somebody, right? So now I'm jumping across multiple traversals of the graph. However, in the AI use case, I think it is much less common for AI to do long-range traversals. What we do see AI doing is incremental discovery of a graph. And that is, so, hey, I'm going to do a query, I'm going to pull back some results, allow the AI to filter it, and then do an additional set of queries that are pulling in, usually in parallel, the related data, examine those, filter, do another traversal, or do the next lookup. And so that's a very different read pattern. It needs a very different kind of database. Or actually, it does not need a graph database. That's the short version. You can do that with almost any database. So just to be clear there. On top of that, we want to be able to present still to developers and users tools that make it easy for them to build AI that can interface with this knowledge layer. And then last, we're building up to the context window. It's all about building the context that we will ultimately feed to the LLM. So this is the way the knowledge layer tends to shape up for real world applications. So the next part is, great, I have knowledge, but how do I teach or make sure that the models that I'm using are always current and that they're improving? And what do I mean by that? So if we take sort of off-the-shelf models, and I think that if we look at the most AI architectures today at the data layer, they're employing at least 3 different kinds of models. They will have, of course, an LM or 2, or maybe throw a small language model in there too, but I kind of group all of those under one bucket. It's very, very common now, obviously, to use embedding models. Those are what enable vector search, vector similarity search. And the last that's becoming very common are re-ranking models. And re-ranking models allow us to use something kind of like the LLM level of intelligence, but just to re-rank the results in terms of a relevance relative to a query. So for example, vector search does that already, but it does not have quite the level of intelligence that a re-ranking model brings. So we combine all of those together to get the most relevant results on the shortest list. So we want to get just the top few most relevant results to feed to the LLM, because historically with just brute force vector search, we would say, well, I'll just get more results and just throw it at the LLM and then it'll sort it out, which often it did surprisingly well. However, we're finding that the LLM, the more distractions that we give to the LLM, the more likely it is to hallucinate or misinterpret, especially if the results are potentially applicable to the original query. So, but as we're going forward, we need to make sure that our engineering organizations and the architectures that we deploy have a built-in method of collecting data about the way the system is used, and employing that data to fine tune those three classes of models, at least those three classes of models that I just mentioned. Particularly being able, I mentioned small language models to large language models. What we're seeing is that if you can use a large language model in a system like this, collect usage data, and really come to understand the way that your users use a given corpus of data, collect that information, fine tune that into a small language model, and lean more heavily on that as the small language model is able to deliver the same quality or better quality of results as the large language model. That allows us to have a very clear path to reducing costs and while maintaining or improving the end user experience. But if that sounded all complicated, it is, and we need new levels, new tooling in our application stack. And these are the main pieces. We need, obviously, looking left to right, apps and devices, ingress, our regular deterministic APIs, our AI APIs. We need some tooling to coordinate access to data ingestion, processing stuff like data extraction from content, classification, tagging, things like that. Being able to run an ever increasing list of models. I think another thing I've seen with a lot of enterprises is they really want to just try to standardize on one model. They want to find what's the one model we can depend on, and we're going to just focus on that one. That's actually not a good strategy. We're definitely starting to see that different models have different strengths, and I think a lot of it has to do with the data that they're trained on. For example, if you look at XAI and that the models that they produce, well, those models are predominantly trained based on social media data collected from X. Whereas from Google, some of the Vertex and Gemini models, a lot of the data that they're trained on is going to be search data or advertising data, the way people use that system. Whereas OpenAI may be able to pull from chat interactions. So I think that what we're going to see is over time, depending on the use case, there's going to be different models that are more or less appropriate or stronger or weaker relative to a given use case, in addition to having a different cost profile. And another reason that DataStax has built this partnership with NVIDIA is that many of our customers, they really want to be able to run their models on premise or in their own self-managed infrastructure. There's some significant cost gains to be had if you have a sustained high workload. If you have the workload to justify it, then running on premise, being able to have a capex on GPUs as opposed to an opex for a model provider can yield considerable savings. There's a lot of ifs in there. If your workload's spotty, it's not sustained or high, you may still find that using a third-party model provider is more cost advantageous. Either way, having a clear way to deploy on self-managed models if you want to, or having a mix of some self-managed and some hosted, you need an infrastructure, an architecture that looks something like this. So just to give you an idea, here are some of the specifics of that conceptual architecture I just touched on. So if we go through some of this, I know I'll give you just a second to digest this. There's a lot going on this slide. But if you sort of refer back to the conceptual diagram, everything's pretty much in the same place. But the big piece is over here, we needed this additional path that can absorb the way that data is in our system is used, that is sort of metadata, and leverage that for both compliance considerations as well as model fine-tuning and training. And that's where these other NVIDIA components come in: curator, customizer, and evaluator. And NVIDIA makes these low-level components, but DataStax with our LangFlow product make them easy to use. And I'll show you that. If you're not familiar with LangFlow, I'll show you that very briefly in just a moment. And then all these other components come into play. Retriever, NIM is all of the models. Blueprints are sort of stock starter apps that NVIDIA produces. And then Guardrails has been an essential component of pretty much every AI app that I've seen deployed. That's basically being able to have some control over the inputs and outputs of what goes in and comes out of the LLM. and being able to be declarative about that. So for example, the obvious ones are like abusive language or inappropriate language, but there's some other more subtle ones, like if the user is getting off topic. You don't want to just be running another proxy to chat GPT for your end users. You want to keep them on topic. And so if they get off topic, you want to let them know. Or maybe they want to bring up some political topics, and you're an e-commerce vendor, you don't want to entertain that or waste tokens entertaining that conversation, or some other things like don't talk about our competitors. That's going to be a very common question for consumer facing, like e-commerce use cases. Again, how does this product compare to your competitor? And you want to make sure that you short circuit that. Don't even give the LLM an opportunity to reply. You want to say, we don't really talk about our competitors, or whatever the stock non-answer you want to give. And so guardrails is a very important part of that consumer-facing interface, and it's essential to every part of every AI stack I've seen. But central to this is the knowledge layer. That's the piece that DataStax provides primarily, and it is the foundation for enabling all these other pieces, being able to perform traditional lexical search, semantic search, which we talked about, the knowledge graph, structured data, streaming. We'll talk a little bit about that. Obviously, DataStax provides a streaming product, and semantic caching. Now, you may be familiar with caching in general. Semantic caching is, I think, a version of caching that is more suited to being able to cache users' queries and then the responses that we traditionally generate. So if you can, because what we found is that in many both search and AI use cases, it turns out that a lot of our users ask the same questions over and over. In many cases, they ask the exact same question. But particularly when we are encouraging users to have long-tailed queries, that is like a dialogue, the odds on their query not being an exact match with someone else's query, but being really, really close, like semantically close. Well, we can leverage vector search on the key side of a cache to be able to find questions by key that are very similar and provide stock answers. That helps us lower latency and control costs, and while maintaining the exact same user experience. So that's where the semantic caching comes in. I could go into a lot of detail why our databases are particularly well suited to that need. But some of the other sort of pieces we'll be talking about briefly in a moment. Data lineage, we mentioned earlier. You need to have a path to be able to understand where your data came from, where it's going, how it's being used, particularly for regulatory compliance needs. And that needs to pair very well with sort of a governance tool that gives you the dynamic capability to enforce geographical regulatory requirements, that is dynamically understanding the laws of a given region and how a prompt may or may not be permissible, or a response may or may not be permissible, and being able to do that at runtime. And that's another part where watsonx governance come in, serving a very real need. Okay, I do want to give you guys the option or an invitation to ask questions if you have any. Let me see, let me just pause, go check to see if I have any questions. I do not yet have any questions. Again, I want to encourage you, if you have, there's a question and answer tab, please ask questions in there, and I will check in on those in just a minute. Back to these pieces. So I kind of already talked through some of these, how DataStax leverages many of these NVIDIA integrations to bring these state-of-the-art technologies to your on-premise, either your self-managed or cloud cloud-managed architecture. I'll take just a second to show you what Langflow is and how it matters. This is on datastax.com. You can go to datastax.com, sign up for free if you haven't already done that. Go in here, click, and we have this little drop down gives you access to our hosted Langflow and our hosted database. So all of the data products I'm talking about hosted in AstraDB. But in Langflow, just to give you just a very quickly, if you haven't seen Langflow before, very easy getting started experience. You can come in and say, okay, well, I'm going to build an assistant, and you can click this, and as an example, let's say this invoice summarizer, I could click that, and it's going to immediately give me a drag and drop UI that guides me through how I can build a working API that provides this, this summarizer and an invoice summarizer in this case. Obviously, this is just a getting started place. We have a prompt template that you can define here. This is able to go retrieve using the Needle API. And then here's your chat input and output. And then we're running these through this agent. And in this case, we're using OpenAI. We make it very easy in Langflow for even non-technical users to just fill in the blank with all the right values and then wire that together with, again, remember this input and this output because they're kind of special. Those wire directly into the playground. So you can see this is the prompt that I had constructed there, and I can interact with this just like I would with any sort of chat app like we're kind of familiar with. So I, as either a user or a developer, could use this API. I don't have my Needle API there key, so I'm not going to go and run that. But I think one of the most powerful parts about Langflow is the fact that you're not this input and output, not only do they wire into the playground, but they also wire into an API. So I like to use the curl pre-built code as an example. This field right here, see this input value? So I can immediately use this in my Python code, JavaScript code, or just do a smoke test right here from curl. And this is a running API right now exposed via HTTP if I had my token, which you do have to put that in there in your code. And then I would supply this input value. That would be the exact same as if I had actually just typed it down here. And so very convenient user interface. We provide all of the most common vector stores that you might use. We provide all of the most common models that you might use. Obviously, we have like all the usual suspects in here. It's very easy to just say, hey, I'm just going to like drag and drop Watson X here, and I'm going to use that as a model in my flow. Obviously, the agent has the models built in here too, so you can just very quickly click to the provider and then put in your API keys. So very, very convenient and a tool that's all drag and drop, and you just wire these things together, and boom, you have a working API. Super powerful and fun app if you haven't worked with it before. So back to why that matters is we have the drag and drop components, just like what I showed you there, for all of the NVIDIA components, such as their models, guardrails, retriever, evaluator, customizer. I will tell you that evaluator and customizer right now are in beta, so you're not going to see them in our hosted version. They'll probably show up in the open source version of Langflow first. Well, I don't know. We'll see. It could be one or the other. But if you didn't, I didn't mention that earlier. Langflow is an open source product. You can run it on your own infrastructure. I just like to show it off on our hosted version because it makes it very easy for you to get up and running and start experimenting before you decide, okay, I want to put in the effort to install this locally. Although I will tell you, if you're running on a Mac or Linux, it's literally just pip install Langflow and you'll be off to the races. It really couldn't be any easier to get started. Okay, I mentioned earlier some of the data products that DataStax provides. Our Astra streaming is built on top of Pulsar. We provide an interface to Kafka. Our OpenSearch integration provides access to BM25, neural sparse vector, many other kinds of very sophisticated searching. Cassandra is our high scale vector search. So you can think of OpenSearch as this is where you can get started if you have small to medium sized use cases. But if you have some really heavy use cases, very beefy, super high throughput, whether reads, writes, it needs to be highly scalable. Cassandra has really defined the market in that area. And then of course the Langflow thing I was just showing you. Getting into governance, I think that for those of you who don't know, IBM has just recently declared their intent to acquire DataStax. We are not actually part of IBM yet. However, I've started to become more familiar with their product lines. I mean, they are a partner of ours. So in the context of being a DataStax partner, I will tell you that this is a really very sophisticated tool. watsonx Governance, if you haven't seen it or heard about it, and you have, especially if you try to run businesses in multiple geographies, or if you would just want a tool that helps you, sort of keep on top of how your AI tools are being used, help you build prompts and things that are compliant. This tool has some very fascinating capabilities. I'm not going to spend a ton of time on it. I will say that there's you can Google for either watsonx.governance, or they have an article they link from there called Enterprises Need a Streamlined Approach to Managing Regulatory Compliance to Scale AI. That's quite a title. But the article that they posted there, I think, does a pretty good job sort of breaking down many of the different features that we need to run our business and make sure that we're staying in compliance, and to give our engineers tooling to do many of these things. What I have seen is that most of the enterprises I work with have reinvented this wheel. Like, they've built all this stuff themselves, and now they're in this painful position of trying to maintain some software that they're really not well versed in, and trying to have technologists and or product managers stay abreast of regulatory changes that are coming out incredibly quickly, and they're very different across different geographies. It's too much to ask of our engineering teams. I think it is a prime area to partner with a company that has been doing this kind of thing for a very long time. They're very well versed, and this is a specialist. This is definitely a product that you want to delegate to a specialist tool, not try to in-house yourself. So that's governance. The next one, I'm also going to recommend another IBM product they're just releasing, IBM Manta Data Lineage. Now, if you remember earlier, I talked about graph databases, particularly when they're consumer facing. Often they're not the right, that's not the right choice for that use case, especially with AI and the way that AI is iterative in the way that it queries databases. However, tracking data lineage is a graph problem, and it does lend itself very well to graph databases, which is what IBM Manta is built on, as a real graph database. And I think that one of the bigger challenges that you're going to run into with lineage is being able to just harvest that, keep track of it, and build build a data model that is tracking that lineage correctly. That's where IBM Manta Data Lineage comes in. I'm not going to spend too much more time talking about this, other than just encouraging you to take a look at it as a potential solution for your data lineage needs. I mentioned briefly earlier, I mentioned Model Context Protocol, or MCP. I think that if you are not, I mean, I'll just share with you my own experience. When MCP was first announced, I was very skeptical. I looked at the documentation and I thought, yeah, okay, great. This is another interface. I get it. Yes, okay, it does have an AI styled service discovery thing. Okay, well, I've seen service discovery in integration before, not impressed. And so I kind of looked away from it. However, what I came back, and two things changed my mind. One was the ridiculous growth of the ecosystem. Uh, Compared to how long MCP has been out, and the number of products which have gone ahead and written an MCP server interface to them. I'm talking basically every database and Slack and all kinds of other products. They've already written the interface. And unlike the interface work that we have had to do in the past, so usually what would happen is a vendor would say, okay, here is our interface and it's compliant with REST or SOAP, or whatever the interface it's compliant with. And then it's on me to go author that my side of the interface, and I have to understand their specification and yada, yada, yada. Well, that's where MCP is different, because what happens is I just register the MCP server as a potential target endpoint for my whatever tool I'm using, whether it's my software or my LLM client or whatever. I just say, hey, there's this MCP server. Here's the way to activate that, which could be a URL, could be a local standard IO. That's the way it started out. Incidentally, that was a part of the reason I was also turned off by MCP at first. At first, MCP came out, you could only like run programs through standard IO. Basically, I could run compute things that were on the server that I was already on. I was like, okay, this is silly. But anyway, they have evolved that. Now they have an HTTP interface also that is compliant with server sent events, or SSE. So it does support the idea of sort of bidirectional push notification. But also, each of these MCP servers are compliant with sort of, again, I talked about a discovery mechanism, and a standard set of ways that the LLM can know to interact with the MCP server. So it can say, hey, I'm an MCP server. I have these functions that you can call, And these functions expect these arguments, and the arguments are of these type, and here is what they do. And I can say I also have these other resources available. And there's like I think four or five different types of resource that the MCP server can expose. And what we're seeing is that just the LLM providers are all sort of standardizing. This originally came out of Anthropic, but then we saw OpenAI not very long after, which are competitors. They standardized on it. And we're seeing, I think, most of the other model, there's enough momentum that all the other model providers are starting to um, implement support for MCP. And I don't have a slide for A2A, agent to agent. It's a very similar, like on the surface, if you look at model context protocol and then you look at the agent to agent specification, it's very easy to feel like these have a lot of overlap. And you would be right. There is a lot of overlap. I think we're still my jury is still out on whether or not A2A will survive, or if model context protocols will completely supplant it. But right now, there are a couple of, I think agent to agent, the big difference for that is I think that it's intended to have sort of a service discovery, sort of like DNS, so that you could, so that if I had an agent that I was writing and I wanted it to be able to go look through a directory of tools and find a tool that might work and then register to be able to call it and then call it. And then behind the scenes, that might use MCP. I don't know. We'll see. So, but right now, I think model context protocol is a very safe bet. Agent to agent, you should probably keep your eye on it. There's a couple of other competing protocols, but I think those are the big ones right now in terms of intelligent interfaces. So again, I just want to encourage you, definitely take a look at this. And I think you'll find that it's actually pretty useful and it's very well suited to the needs of AI. And you think about what I talked about earlier with the knowledge layer. The knowledge layer is about taking my data and presenting it in a fashion that is favorable to the AI to work with. MCP is a very similar, philosophically similar, in that we're providing an AI friendly way for to use different functionality. Okay. So the last one we're going to talk about is this sort of AI. Well, we'll talk about our organizations. And when we look at this AI POC to production gap has been a huge problem over the last 2.5 years. In some of I've talked to a couple of GSIs executives who told me, look, we want to hear about apps that make it to production. We've done 1,000 POCs, not exaggerating. And just show me production, show me getting to production. And so I think that if we kind of look at this trend, in addition to understanding the architectures that I just showed you earlier, now we understand how to deploy those, we understand how to do interfaces, but now this is what's changing in our organizations. Now, again, this is kind of like I was talking about earlier. You might look at this and say, okay, well, these are just coding tools. That was that slide I mentioned very early in the presentation. But this is how the tools we have are being used. So traditional programming here, this is what we expect to see over the next few years. The way that we write code now is going to change. And I'm not saying change a little. It's going to change uh, incredibly. It's and this will get. I'm sure this video gets saved on YouTube somewhere, and people will be like, "Oh yeah, it changed way faster than you thought." When they look back on this, we're seeing one of the most viral trends in building software that I've ever seen. It's start right now. They're currently, it's currently being referred to as vibe coding, but I think that it'll become much more formalized as we understand the ins and outs of the workflows and the right way to tool it. We'll see an emergence, I think, of a new range of tools that are targeting an even less sophisticated user than the current vibe coding tools that are out there now. So what's going to happen is we're going to see product managers and um, uh, domain specialists who are suddenly going to be able to write software that works on their own. I say write, I should say build, because they won't be writing it. They won't be actually looking at the code any more than they look at the code today. But I want to strongly encourage you as you think about your organizations and how this trend, think about the ripple effects that it will have through your organization to be able to deliver software in like a tenth or a hundredth of the time that you had previously. I mean, ridiculous speed ups. How does that change? How does it change your workforce if now you're favoring um, people who have ideas and understand a vision of what you're trying to create more so than you're accommodating the people who are down, turning the knobs and implementing the code, so to speak. So this is going to have profound effects on, again, staffing, the way we go to market, how quickly we can put out new products and test them, get customer responses. And then if we wire that into an infrastructure, an architecture, like I mentioned earlier, that can learn very quickly, and it's going to be so critical for us to be able to have that level of agility in understanding how users' behavior of a given data set changes over time and being able to keep the models keeping up with that behavior. So this is definitely a trend. You is if you take nothing else from this deck or from this presentation, pay serious attention to this trend, as this is going to impact every one of our jobs in this field incredibly. And again, these are some of the tools I just mentioned. If you want some guidance, I would definitely direct you to look in the top left corner. Of course, I think Langflow plays an incredibly important part here in terms of ease of use and AI development. But to really get a visceral feeling for what this movement is and how this new level of code generation is going to change things. My favorites are Claude Code. Replit is a really low barrier to entry, sort of get your feet wet, kind of to try it out. Cursor is very, very popular right now. So you can definitely look at that. And one didn't make it into this slide, but OpenAI has a tool now called Codex, and then they also just acquired Windsurf. OpenAI acquired Windsurf. So definitely get your hands on those. Understand those, because if you don't, then you're going to definitely be caught off guard when some parts of your organization are generating code at a ridiculous rate, or new people are generating code, and the cost, this changes all the cost dynamics around engineering, all the cost dynamics around staffing, the way that we plan. So budgetary planning over, a 1 year or 5 year plans, forget that. 5 year plan when involving software, you're gonna have to think much, much shorter. Okay, so that is my whole presentation. I want to take just a little bit of time to take any questions if you have any, or commentary. I'm very curious to know if you guys have already started working with many of these vibe coding tools, or if you're familiar with them, or if you have an architecture that is very similar to the architecture we have here. I'd definitely love to hear about it. And thank you, Michelle. Put a link in the chat to Langflow. You can go sign up there for free and get your hands on it and start to experiment with it. All right. I'm going to give you one more minute, and if we don't have any questions, I'll wrap. Okay, don't see anything in there. All right. Well, I hope this was informative to you, and I encourage you to go dig into all the tools that I exposed you to. If you have any questions, feel free to reach out to DataStax, and we'll be very happy to help you with a longer individual presentation about any of our products or how we use those to help you solve your business problems. So thanks a lot.